Finding quadratic models. To find an equation of a quadratic model given some data, 1. Create a scattergram of the data. 2. Imagine a parabola that comes close to the data points and choose 3 points, not necessarily data points, that lie on or close to the parabola. 3. Use the 3 points to find an equation of the parabola. 4. Use a graphing calculator to verify that the graph of the equation comes close to the points of the scattergram. A quadratic regression equation is the graph of best fit for the data. Its graph is referred to as a quadratic regression curve. Determining which type of model to use. Selecting a model. When performing step 1 of the modeling process, we must decide whether a linear function, an exponential function, a quadratic function, or none of these is suitable for modeling the situation. Here are the criteria for selecting a model. The graph of the model should fit the points well. The model should make sense within the context of the authentic situation. 4-step modeling process. To find a model and make estimates and predictions, 1. Create a scattergram of the data. Decide whether a line, an exponential curve, a parabola, or none of these comes close to the points. 2. Find an equation of your model. 3. Verify that your equation has a graph that comes close to the points in the scattergram. If it doesn't, check for calculation errors or use different points to find the equation. An alternative is to reconsider your choice of model in step 1. 4. Use your equation of the model to draw conclusions, make estimates, and/or make predictions. In this example, domestic airline fuel prices are shown in Table 42 for various years. For the year 2000, domestic airline fuel price in cents per gallon is 80. 2001, 78. 2002, 71. 2003, 84. 2004, 115. 2005, 165. 2006, 195. 2007, 209. 2008, 310. Source: Bureau of Transportation Statistics. Let F of T be the domestic airline fuel price in cents per gallon at T years since 2000. Find an equation of F by hand. First, we should get an idea of what our data looks like. Since we're dealing with time since the year 2000, we want to let T equal 0 for 2000, 1 for 2001, 2 for 2002, 3 for 2003, 4 for 2004, 5 for 2005, 6 for 2006, 7 for 2007, and 8 for 2008 when we type our data into our calculator. Once we go to our calculator, we want to go to the Stat menu, Edit. Now we're ready to type in our data. Under L1, that's where we want T. We'll have 0, 1, 2, 3, 4, 5, 6, 7, 8. For L2, we want to type in the domestic airline fuel price in cents per gallon, which will be our F of T. 80, 78, 71, 84, 115, 165, 195, 209, 310. Now that we have our data, we are ready to graph. First, I'm going to go to y equals, just to make sure I do not have a graph in there already. Clear. Now, to make sure that I can plot my data, second, y equals a stat plot. Plot 1 is off, so I press enter. When it's blinking over on, press enter. I want the scatter plot, which is the first choice. My X list should be L1, my Y list should be L2. Go to zoom, and 9 zoom stat is best for plotting points from L1 and L2. Looking at our data, it doesn't form a straight line, so we need to decide if this is exponential or a parabola. The reason we want to go with a parabola is it looks like our data goes down, has a vertex, then goes back up. Given our data points, 0, 80 as one of my points, 4, 115 as a second point, and 8, 310 is my third point. Now, we can use other points if we want. Any of the points would probably be a good choice except for 7, 209 because it's outside the curve of the rest of our points. Now that we've chosen our 3 points, we want to use y equals ax squared plus bx plus c to help us find our a, b, and c so that we can write our equation. Using my first order pair, substituting y is 80 equals a times x, which is 0, squared, plus b times x, which is 0, plus c. So that gives us 80 equals c. So we already have one of our 3 variables. Using 4 and 115, my y is 115, and that's going to equal a times x, which is 4, squared, plus b times x, which is 4, plus c. So that result is 16a plus 4b plus c equals 115. Using 8 and 310, I substitute 310 for y, so 310 equals a times x, which is 8, squared, plus b times x, which is 8, plus c, and our result is 64a plus 8b plus c equals 310. Now that we have our 3 equations, we want to find b and a. Given that we know c is 80, I can substitute for c 16a plus 4b plus 80 equals 115. Subtract 80 from both sides, 16a plus 4b equals 35. Then, using my equation for my order pair 8, 3, 10, 64a plus 8b plus c, which is 80, equals 310. Subtracting 80 from both sides, 64a plus 8b equals 230. Looking at what we know, we can now eliminate either A or B. Finding the least common multiple for 4 and 8 will be a little easier than finding it for 16 and 64. The least common multiple for 4 and 8 is 8. If I multiply 16a plus 4b equals 35 by negative 2, I'll have a negative 8b, which when I add to 8b should cancel. Multiplying by negative 2, 16a times negative 2 is a negative 32a, plus 4b times negative 2 is negative 8b, equals 35 times negative 2 is a negative 70. Then I rewrite my 64a plus 8b equals 230. And now I am ready to add. Negative 32a plus 64a is 32a. Negative 8b plus 8b is 0. Negative 70 plus 230 is 160. Dividing both sides by 32, a equals 5. Now that I know A and C, I can find B. Using 16A plus 4B equals 35, I'm going to substitute in my A. 16 times 5 plus 4B equals 35. 16 times 5 is 80, plus 4B equals 35. Subtracting 80 from both sides, 4B equals negative 45. Dividing both sides by 4, B equals negative 11.25. Now that we have A, B, and C, we can write our equation for f of t. So if A equals 5, B equals negative 11.25, and C equals 80, f of t equals 5t squared minus 11.25t plus 80. We can check this by going to our calculator, graphing our parabola to see how close it comes to the points of our table. On our calculator, we want to go to y equals, then under y equals type in our parabola, 5x squared minus 11.25 x plus 80. Then graph to see if it passes through our ordered pairs. Our parabola does come very close to most of our data points, and it does pass through the 3 data points that we chose. So we have a good representation of our data with our parabola. In this example, find a regression equation of f by using a graphing calculator. We're still using the same data with the domestic airline fuel prices table. So we want to go to the calculator, go to our stat menu, arrow over to calc, and we want number 5, which is quadratic regression. Our x list we want to be L1, our y list L2, the frequency list we're going to keep blank, the store regression equation we're going to keep blank, arrow down to calculate. Then press enter. And we have our values for A, B, and C. We'll round to the tenths place. So A is 4.6, B is negative 9.6, and C is 78.9. Go into mode. Not all of the calculators have the stat wizards, so I'm going to turn this off, enter. If you want to see if your calculator has it, you can go to mode, just like I did. I'm going to go through the same thing again, stat, over to calc, down to 5. That should be the same no matter what calculator you have. Then you have your quad reg. You need to tell it where the data is. It's in L1 and L2. Second, 1, comma, second, 2. Quad reg L1, comma, L2. Press enter, and you'll get A, B, and C as well. So A is 4.6, B is negative 9.6, and C is 78.9. Our equation will be f of t equals 4.6t squared minus 9.6t plus 78.9. In this example, compare the graphs of the two models. We're still using the data from the domestic airline fuel prices table. Going back to our calculator, go to y equals and arrow down to y2, and here we'll type in our new equation. 4.6 x squared minus 9.6 x plus 78.9. Graph. And the green graph is the regression equation that the calculator came up with. As you can see, it's very close to the regression equation that we came up with using 3 points from the parabola. In this example, July is the most popular month for Americans to take vacations. Let f of t be the percentage of Americans who take a vacation in the month that is t months since July. For our table, for the month of July, the number of months since July, t is 0, the percent is 43. For August, t is 1%, 34. September, t is 2%, 21. October, t is 3%, 15. November, t is 4%, 11. December, t is 5%, 11. January, t is 6%, 3. February, t is 7%, 3. March, t is 8%, 4. April, t is 9%, 8. May, t is 10%, 20. June, t is 11%, 30. Source 2001 American Express Leisure Travel Index. Part A. Use the data for August, October, and May to find a quadratic function of f. So the data that we want to use for August, we're going to have the point 1, 34. For October, we're going to have the point 3, 15. And for May, we're going to have the point 10, 20. We want to use y equals ax squared plus bx plus c to help us find a, b, and c so we can construct our equation. First, I want to substitute for y and x in the equation using my ordered pair 134. 34 equals a times 1 squared plus b times 1 plus c. That will give us a plus b plus c equals 34 as one of my equations. We'll call this equation A. For my second equation, I will use the point 315. Y is 15. 15 equals a times 3 squared plus b times 3 plus c, which gives us 9a plus 3b plus c equals 15. And we'll let this be equation B. For our last point, 10, 20, y is 20, so that equals a times x, which is 10, squared, plus b, which is 10, plus c, which gives me an equation of 100a plus 10b plus c equals 20. And that's going to be equation C. Our next step is to choose whether we want to eliminate A, B, or C. It's going to be easiest to eliminate C, and since equation A has the smallest coefficients, I want to add equation A to equation B, then add equation A to equation C. Multiplying equation A by a negative 1, I have negative A minus B minus C equals negative 34. Then bring down equation B, 9A plus 3B plus C equals 15. Adding, I end up with 8A plus 2B equals negative 19, and we'll let this be equation D. Still using negative A minus B minus C equals negative 34. I now want to add this to equation C, which is 100A plus 10B plus C equals 20. So we end up with 99a plus 9b equals negative 14. And we'll call this equation E. So now we want to cancel either A or B. Because B has the coefficients of 2 and 9, it's going to be easier to eliminate B. The least common multiple of 2 and 9 is 18. Multiply equation D by negative 9 and equation E by a positive 2. That way I will have a negative 18b and a positive 18b. Negative 9 times 8 is a negative 72, bring over my a, plus negative 2 times 9 is negative 18b, equals negative 9 times negative 19 is a positive 171. Multiplying equation E by 2, 2 times 99 is 198a, plus 2 times 9 is 18b, equals 2 times negative 14 is negative 28. Now I'm ready to add. 198 minus 72 is 126a. Negative 18b plus 18b is 0, so that equals 171 minus 28, which is 143. Now we want to divide both sides by 126. So 143 divided by 126, enter, is negative 1.34920635. When you have a decimal, you want the most accurate answer possible. So for our further calculations, we want to use this answer. But for now, we're going to round it to 1.13 for our work. A equals 1.13. Now that we have A, we can find B. I can use either equation D or equation E. So I'm going to use equation D. 8 times 1.13 plus 2b equals negative 19. Going back to my calculator, all I have to do is type times 8, and it will take the answer from the previous problem, multiply it by 8, enter, and I get 9.079. I'm going to round it to 9.08. Go back to my work. 9.08 plus 2b equals negative 19. I want to subtract both sides by 9.08. 2b equals, going to my calculator, I will have negative 19 minus my previous answer. So if I press second and the negative, it will type in answer. Enter, and I get negative 28.079, which will round to negative 28.08. Then divide both sides by 2, calculating. So I can just go to divide 2, enter, and I have negative 14.039, which will round to negative 14.04. So B equals negative 14.04. For C, it's going to be a little harder to keep my answers accurate as I did for A and B, unless I keep A and B as fractions. I'm going to use equation A. A is 1.13 plus B, which is negative 14.04, plus C equals 34. So 1.13 plus a negative 14.04 is negative 12.91 plus C equals 34. Add 12.91 to both sides, and C equals 46.91. If A is negative 1.13, B is negative 14.04, and C is 46.91, our equation will be f of t equals negative 1.13t squared minus 14.04t plus 46.91. In this example, we're still using the percentages of Americans who vacation by month table. Part B, the data for July, August, and September lead to the equation f of t equals negative 2t squared minus 7t plus 43. The data for November, December, and January lead to the equation f of t equals negative 4t squared plus 36t minus 69. The data for December, March, and May lead to f of t equals 2.07 t squared minus 29.2 t plus 105.33. In Part A, you found yet another equation of f. Use the graphing calculator to determine which of these four triples of months gives the best model of the data. Including the equation we just found, f of t equals negative 1.13 t squared minus 14.04 t plus 46.91. We want to enter our data from the table in our calculator. Under y equals, enter our four equations. Then we want to graph to see which of the four equations best matches that data set. Going to our Stat menu, Edit, we have data here. If you arrow up so that the list is highlighted, press Clear and Enter, it will clear that list. Under L1, we want to type our number of months since July. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Moving over to L2, we now want to type our data under percent. 43, 34, 21, 15, 11, 11, 3, 3, 4, 8, 20, 30. Now we're ready to enter our graphs. Y equals. If you need to get rid of an equation, you can just press Clear, then Enter. Our first parabola is for July, August, September, which is negative 2x squared minus 7x plus 43. Enter. Our next parabola is for November, December, and January, which is negative 4t squared plus 36t minus 69. Enter. Our third parabola is for December, March, and May, which is 2.07 t squared minus 29.2 t plus 105.33. Enter. And now we want to type in the equation that we came up with for August, October, and May. Negative 1.13 x squared minus 14.04 x plus 46.91. And remember, the variable x and t are interchangeable. Go to Zoom, 9. It's very easy for us to see all of our data points. It's kind of hard to see all of the parabolas. So going to Window, I want to change my X-min so I can see more to the left. So I'm going to pick negative 10. The X-max should be fine. I'm going to leave the scale. The Y-min should be fine, but I want to see up a little bit more. So I'm going to change my Y-max to 60. Graph. We'll see if that helps. And now that we can see more of our parabolas, the parabola best fit seems to be our orange parabola. Trace, and my red dots are my plot, arrow up, and I have my pink parabola, which was the one that we found, arrow up, and the orange parabola is the data for December, March, and May, which seems to be the best fit for our data. So which of the four triples of months gives the best model of the data? December, March, and May, which is f of t equals 2.07 t squared minus 29.2 t plus 105.33. In this example, China has manufactured so many solar panels that it has created an enormous oversupply. The numbers of gigawatts of solar panels manufactured in China and the numbers of gigawatts of solar panels installed in the world are shown in the table for various years. For the year 2007, solar panels manufactured in China, gigawatts, 2. Worldwide solar panel installations, gigawatts, 3. In 2008, manufactured, 3. Installed, 6. 2009, manufactured, 8. Installed, 7. 2010, manufactured, 16. Installed, 18. 2011, manufactured, 38. Installed, 27. 2012, manufactured 50, installed 31. Source GTM Research. Part A. Let F of t be the number of gigawatts of solar panels manufactured in China, and let G of t be the number of gigawatts of solar panels installed in the world, both in the years, that is t years, since 2000. Find the quadratic equation of F and a linear equation of G. Our first step is to decide what we're going to put in our calculator for our data set. So for L1, that's going to be our year T. L2 will be the solar panels manufactured, and L3 will be the solar panel installation. Since we're starting with the year 2000, my first T will be 7. L2 would be 2, and L3 would be 3. 2008, we would have 8, 3, and 6. For 2009, we would have 9, 8, 7. For 2010, we would have 10, then 16, and 18. For 2011, we would have 11, 38, and 27. For 2012, we would have 12, 50, and 31. Then we want to go to our calculator and type in our data. On our calculator, go to Stat, Edit. If you have data, you can clear it out. Under L1, we want to type 7, 8, 9, 10, 11, and 12. Moving over to L2, we want to type 2, 3, 8, 16, 38, and 50. Moving over to L3, we want to type 3, 6, 7, 18, 27, and 31. We are going to have two dot plots. One dot plot will be the year and the solar panels manufactured, which will be L1 and L2. Our second dot plot will be our year and the worldwide solar panel installations, which will be L1 and L3. To get to our stat plot, second, y equals. Our first stat plot is on, and it uses L1 and L2, which is what we want. We need to turn on plot 2. Arrow down, enter. We want it on, so press enter. The type is the dots. XList is L1. YList we want to be L3. Second 3 will type in L3 for us. Go to zoom, 9. Our red dots are the dots for the solar panels manufactured, which looks like a parabola. Our blue dots are for the worldwide solar panel installations, which looks more like a line. So we have to find our quadratic equation of f and our linear equation of g. Let's start with our quadratic equation. Go to Stat, over to Calc, and we want our quadratic regression, which is 5. Our x list is L1, our y list is L2. We don't have a frequency list. We can store our reg equation. Go to the VARS button, arrow over to y variables. We need function, and we want it in y1. Then arrow down to calculate and press enter. For our quadratic equation, our a is 2.196, our b is negative 31.646, our c is 115.507. If you don't have the Stat Wizard, you can go to Stat, over to Calc, and we want number 5, second L1, comma, second L2, comma, and then go to your VARS menu, over to yVars, function, enter, y1, enter, enter, and it will give you the same information and also put your equation in y1. So the quadratic equation for f is f of t equals 2.20 t squared minus 31.65 t plus 115.52. Now we're ready to find the linear equation for g. Again, go to Stat, over to Calc. We want the linear regression this time, which is 4. Our x list is L1, but we want our y list to be L3. Second and 3, we'll type in L3. We don't want anything for the frequency list, but we want to store our regression equation in y2. VARS, over to yVars. We do have a function, so press enter, and then arrow down to y2, enter. And now we're ready to calculate. Enter. So for our linear regression, our slope is 6.11 and our y-intercept is negative 42.75. So if you don't have the Stat Wizard, you can still do this by going to Stat, over to Calc. We want number 4 again, and this is where it's a little different. We'll type in L1, which is second 1, comma, L3, which is second 3. Still go to our variables menu. We still want y variables. We still are using a function, and we want y2. And I forgot my comma, so I arrow back, second, insert, comma, and now I should have L1, comma, L3, comma, y2. Enter, and we still get the same thing for our slope and our y-intercept. Find a linear equation of g. We have g of t equals 6.11 t minus 42.75. Part B. Use intersect on a graphing calculator to find the intersection points of the graphs f and g. What do these points mean in this situation? If you go to y equal, our equations are already there. So go to graph, and we see that our blue parabola goes through our red dots, and our green line goes through the blue dots. Since I can see where they cross, I can use my intersect. So go second, trace to get to the calc menu. Number 5 is intersect. Arrow over to where you think they cross. So for my first curve, yes, it's where I think they cross, enter. Second curve, enter. Guess, enter. And my intersection is 9.95 and 18.09. So it's approximately x equals 10 and y equals 18. So I'm going to click trace. On our line, when x was 10, which is 2010, is when they were equal, I'm going to my left, and I have a second point of intersection. So second, calc, 5, So I'm going to arrow to the left just a little more to get close to that curve before I press enter for my first curve, enter for my second curve, guess, and I have an intersection of 7 and 1.5. So what this tells us is that in 2007 and 2010, that's when manufacturer met demand. From 2007 to 2010, fewer solar panels were manufactured than needed. Then after 2010, more solar panels were manufactured than were installed. What do these points mean in this situation? For the point 7, 1.5, in 2007, the number of gigawatts of solar panels manufactured and installed was 1.5. 1018 in 2010, the number of gigawatts of solar panels manufactured and installed was 18. So in those 2 years, the number of solar panels manufactured and installed were the same. Finding quadratic models. We have a 4-step modeling process. To find a model and make estimates and predictions, 1. Create a scattergram of the data. Decide whether a line, an exponential curve, a parabola, or none of these comes close to the points. 2. Find an equation of your model. 3. Verify that your equation has a graph that comes close to the points in the scattergram. If it doesn't, check your calculation for errors or use different points to find the equation. An alternative is to reconsider your choice of model in step 1. 4. Use your equation of the model to draw conclusions, make estimates, and/or make predictions.